noted.
Okay, now we're being recorded.
Now we're recording. Does everybody see the slides now? I see in the chat window there's a few folks that aren't seeing the slides. Looks like some people can see them and some cannot. I'm not sure if there's anything we can do. Kristen, do you have any ideas? Not to put you under the bus. Any suggestions for these folks who can't?
If you can't see the slides, I would encourage you to use either Internet Explorer to open the link or Firefox. We've had some issues with Chrome, and that's one of my best guesses. But with other stuff, I'm unfortunately not an expert in Skype for Business or Link.
We apologize if you can't see the slides. It's a bit of a learning experience for some of us, certainly myself, on using this. So we appreciate your patience on this. Just finishing up on some of the housekeeping, just to kind of keep things going here. Please be sure to use mute on your phone and not hold, so that we aren't all treated to the hold music. Some of it can be quite good, but and then, as you can see in the chat window, it's live for everybody, so please be respectful of your comments. But also, please submit your questions to the chat window. Yours truly will be collecting these questions, and then as time allows, we'll go through these near the end of the webinar. So let's move on to a little bit of discussion on what our session is all about today. So what is GitHub? It's the primary tool in today's coding landscape. Not a big fancy term, but basically it's used for managing and sharing files, typically code. That's probably the biggest use of it. Developers across the world use GitHub to share objects and work together to create not only original work, but to improve upon the work of others. And we'll be seeing some examples of this. This webinar will be showing how GitHub works and how it can be used inside of a GIS department or your own organization, whether it's a GIS department or not. But that's the focus here, is the GIS part. It can be used to share and track code, documents, and data, geographic data, and it's quite powerful. I remember at last year's, going off track a little bit, but looking at the previous Magic Symposium, somebody provided a very nice presentation on GitHub, and we actually were able to see a map showing up inside of the GitHub, so it's very powerful. So who are the presenters today? There we go. First off, Kristen Koenig is a GIS specialist with DASC, or the Kansas Data Access and Support Center. Her primary experience with GitHub is collaborating on data verification tools for Kansas's Next-Gen 911 project. She mostly codes in Python, and she also organizes the Kansas Python users group. I don't think that has to do with snakes, does it, Kristen? Next up is Anthony Davis. He's a software development manager for the Arkansas Game and Fish Commission. His primary experience with GitHub is collaborating on the, I'm hoping I'm going to say this correctly, and correct me if I'm wrong, but on the Syriaca.org project, which is a collaborative research project publishing online reference works concerning the culture, history, and literature of the Syriac communities from antiquity to the present, and collaborating on the Arkansas Spatial Data Infrastructure with the Arkansas GIS Office. Okay, I think that's an introduction. At this point, I'll turn over everything to Kristen. Thank you.
All right, thanks. So basically, in a nutshell, GitHub is a platform for sharing and tracking projects being software or document projects. And it's essentially a revision or version control system, which a lot of times you'll hear the acronym VCS. And there are several different platforms that provide this, but GitHub is currently one of the most popular forms of version control system out there. And looking at PowerPoint slides, it only gives you so much in terms of a visual, so we will actually take a look at what GitHub actually looks like. So this is the Kansas GIS account that I operate on GitHub, and to use GitHub you need to have a user account. And this is essentially the homepage that you get to see. It has a little bit of information about the organization, contact information, websites, and then one of the key components of GitHub are your repositories. So these are the collections of repositories that I have, and we will be going through all word definitions that you'll need to know for this. And then also some dashboard metrics down at the bottom, just in terms of activity that has been going on with your particular account or your particular repositories. So just a basic visual of what this looks like. A lot of times with GitHub you will see this cat icon, so just know that if you see the cat around, that's sort of like the F for Facebook, it's the cat for GitHub for some reason. So GitHub has several different helpful aspects to it. It acts as a code repository, which the perks of having a code repository are it has detailed dates and notes of when you conduct updates to your code project. Another helpful aspect with GitHub is that it can handle multiple contributors, and so if you are working on a project with several other people, it will track the dates and notes of updates that all of the contributors make. This is also useful for change detection, so you can tell what has been changed with your project, and again, the dates and notes of the updates. This is extremely helpful. And then the manager of that particular project can accept changes by contributors in a very controlled environment. GitHub also has some other excellent components of it related to social media integration, that they've incorporated a lot of commenting, wikis, bug tracking issues, and a lot of enhanced communication that is inherently difficult in the code development process. So GitHub's actual platform can work with any sort of computer documents, not just code. It can work with Word documents. I've heard of people collaborating on music together on GitHub. Geographic data, Tony's going to talk about that later. And believe it or not, we even conducted a collaboration of these PowerPoint slides on GitHub. However, most commonly it is used for open source code projects, so a lot of software development, collaborations, things like that. But the basic premise is that it syncs documents that are located on your computer with documents that are then hosted online in that repository. And this is also totally awesome for backups and also seeing when changes happen. With a project that I was doing on GitHub and still am, I accidentally on my copy on my computer deleted a huge portion of the code on accident, and so it was excellent to be able to go back to GitHub and be able to copy and paste that code back into my project. Because normally, I'm a normal computer person and totally forget to do backups of my own work, which is a bad habit. And so keeping track of everything on GitHub has been extremely helpful for me in making sure that all that stuff is saved somewhere. So to use GitHub, you need to have a user account. It is free for basic use, but if you're doing more complicated things with it, you do have to pay. One of the caveats with a free account is that all of your repositories have to be public. You can't keep any of that private. But if you do want to keep things private, then you need to pay for a more complicated account. But with your user account, you can follow other groups' accounts and projects. Esri uses GitHub for a lot of their development tools, snippets, add-ins, things like that. And so a lot of GIS users find that to be particularly useful, especially when then they can fix some bug that Esri has and then resubmit it to Esri to potentially fix. GitHub, there's no rose-colored glasses with this. Searching projects can be extremely hard, and merging and resolving conflicts can be pretty complicated. We're not going to get into all that today, but just a heads up that certain parts of it, are a more complicated environment. So just to know that ahead of time. However, there are some perks that you don't even need to have a user account to access free projects that people have out there, and that you can directly access some people's code and copy paste it from the website. And so it's a great resource for people who just need a little bit of code from this or that project, and then you can use that in what you're doing. So next I'm going to go over some key definitions of words that are used in GitHub, and if you're reading documents about GitHub, it's really good to know what some of these things mean, otherwise a little bit lost in translation. So the first key component is Git. Git is a noun, and it's a term for Distributed Revision Control System, VCS, like I talked about before, but this has been run traditionally from command line tools. GitHub expanded on those Git commands and added graphic user interface tools to it. So the next key component of GitHub are the repositories. A repository, a noun, it is a place where the history of work is stored online. And so, for example, this is the repository where we stored all of the documents and PowerPoint slides associated with today's webinar. So from the home page on GitHub, under popular repositories, you can see that I've got a repository for the GitHub webinar for 2015. And so it's just a collection of those documents that we used. And these are the documents that are stored, I'm assuming, on the cloud somewhere, who knows where. And then this way I could collaborate with Tony and also Bob so that we can always all be on the same page about edits that we've done, but then this is where everything is stored so that we always are accessing the same documents. A clone is a noun and a verb, as it is in normal English syntax outside of computer world. But in GitHub, the clone is the copy of the repository that lives on your computer. So the PowerPoint presentation that we're looking at now is the clone of the one that we just saw online. So this one is sitting on my particular desktop, as computer documents do. Then the verb clone is the act of me pulling it off GitHub to put it on my machine. So it's the noun and the verb, but it's just like cloning Dolly the sheep in a way. So forking is a term that's used quite a bit, a verb, and it is basically cloning someone else's repository with the intent of making your own edits and then committing changes that you make back to the owner of that repository. So for example, we're going to take a look at Tony's GitHub. And so this is a repository that he has. So again, we can look at his homepage. He's got a list of repositories. He has another little box here of repositories that he has contributed to. You can see our GitHub repository today. So let's say that I am particularly interested in this project. And it looks fabulous. However, I want to make some changes and then submit it back to Tony. So I can go over here, and on this button that says fork, I click fork, and that's it. It takes a couple seconds. And then slight visual change. Now you can see that we're under my user account, and that repository has now been copied to my list of repositories. So now I can clone this repository to my machine, make changes, and then submit them back to Tony. Basically what I did was create my own branch. This is a new repository that's created by forking someone else's project. And of course, I've always got options with this. I can either turn it into something that is completely my own and take it in a totally new direction, or I can just make edits and eventually get it reconciled back with Tony's project. And so I already showed that, so I don't need to click on that link. So a couple other words associated with actions that you do to documents. Merge is integrating the changes from one branch into another. So Tony, if I decided to make documents or make changes to the documents that I had just forked, I could then ask Tony to merge those changes back into his branch. A commit is mostly a noun, and it's an individual change to a file or set of files, and it's somewhat like doing a file save. Except it's a little bit more complicated than just clicking on one icon. And you can put notes in about what was changed, why you changed it, things like that. And Tony will show you a little bit more about what that looks like. A pull is integrating someone else's changes into your local copy of files. And then a push is sending your committed changes, your saved changes, back up to the remote repository. And if you're a GIS person and have been working in SDE versioned layers for a long time, the pull and the push are a lot like a reconcile and a post when you're working with your version to get your edits back up into other branches ahead of you. So if that ever gets confusing, just think of SDE, and if that confuses you more, then forget all about it. GitHub operates online at github.com, of course, but then there's also a desktop client where you get to control a lot of the back and forth between documents on your machine and with the website. And Tony will show you the desktop client when he's presenting. GitHub has also created several plugins that work directly inside several software development environment projects. I haven't tried any of them, so I'm not going to give you any sort of opinion on what you should use or any of that. That is all for your own development discovery. But those tools do exist. And so now I will turn it over to Tony to give a little demonstration about GitHub and how to get started with it.
Okay, thanks, Kristen. Good morning, everyone. What we're going to do today is we're kind of going to go through a few demonstrations now to kind of talk about what Kristen was talking about, the concepts. Now we're going to show you kind of a real live demo of some real world ways that we can use this. This first demonstration, we're going to show you where to go to sign up for an account, where to go to download and install the GitHub client for your desktop, either a Windows or a Mac. We're going to create our own GitHub repository, and then we're going to clone that to our local machine. So to get started, I probably should present my window first.
I'll stop presenting, so hopefully it kicks it back over to you.
Okay, can everybody see my window? Kristen, are you seeing it?
Yep, looks good.
Okay. Alrighty, so let's get started here. So what we will do is we will go to github.com, and this is where you'll go to sign up for an account. And you literally just, as you do for any website, pick a username, your email, create a password, and say sign up for your GitHub. Once you create an online account, what you're going to want to do is you're going to download and install the GitHub for your desktop. So for Windows, you will click this button, just follow the install instructions, and then for Macintosh, you will come down here and then follow the install instructions there. So what we'll do, since I already have an account, I'm going to sign in. And when you first sign in, you'll see a window very similar to this. You'll have some, getting started stuff up here that I don't have. But what we will do is I'll go to my profile page that Kristen showed you earlier, and you see all of the data repositories that I'm familiar with. But if you want to start a new repository and create one, you'll click on repositories. You'll say new. And I'll call this one Magic Test. And we'll say test repo for Magic. And then I usually put a README file in there. And then when I'll go in there, and it's just going to create a text file, and you can put in there exactly what this repository is for. But if you do that, I'll keep it public because it's the free version, and I'll say create repository. And you can see it created a repository, already put a Magic README file in there. And then what you want to do in order to interact with this, you'll want to clone it to your desktop. It's down here on the bottom right-hand corner on the side there. And when you clone it in desktop, it's going to ask you to launch that application that we installed. which is the GitHub for desktop application. So we'll say launch. And then it's going to ask you, where do you want to store this on your computer? You can literally store this local repository anywhere on your computer. I store it in the GitHub folder that it creates when you install the GitHub desktop application. So I'll say I want to put it there. It's going to download everything from that repository online to my local machine. It's going to say I have everything right now is matching between online and my machine. So what I can do is I can go and create anything. You can create a Word document, a notepad, a C# code, whatever you want to use. And so I will do one, the good old hello world. I will save it to my local GitHub file that y'all saw earlier, that I put this in the magic test folder. And I'll call this hello world. And when I save that file, now when I come in here, GitHub automatically knows that there's a change made, that there's a new file in here that it did not see before the original. When I pulled it from the website, this is something new. So as Kristen said earlier, the first thing you want to do is commit those changes. You want to save those changes to GitHub. So I'm going to come down here and I'll say initial commit. And then you'll want to give a nice little description of what you're doing. And then you'll push this down here that says commit to master. And when you do that, that's going to commit this change to my local GitHub account, the one that right down here, that hard drive down there that we cloned. So then what we do now is if you look at the right-hand corner, you're going to see a sync button. That's telling us that we have one file, that number 1 there, that we need to sync with our GitHub account online. So if I push this sync button right here, it's automatically going to push these changes that I made in this file. The entire file is now going to go out to GitHub. It says everything's now synced. We're good to go. If I come out here and refresh my browser, you can now see that Hello World is here. It's everything that I put in there. But you know what? I made a mistake. That's not really what I wanted to do. I didn't want it to say Hello World. I want to come in here and say Hello Magic World. I'll save that file. Again, it's in my local GitHub file. If I go back to the GitHub client, it automatically sees that I changed it from red to Hello Magic World. I'm going to say commit for magic. I'll commit it to my local GitHub file here on my machine, and now it says, guess what? You've got one file that is not synced to the internet, to your internet version of GitHub. So I'll push sync. And then I should be able to go out here, refresh. And then you can see it has the new description. If I go in here, it now says Hello Magic World. You can go into history. It shows every commit I've made, but if I click on this here, it's going to show exactly what changes were made in this file. So as you can see for coding, this is very important because you can go back, revert, do whatever you need. It keeps track of every change that you make. So with that, we are now going to go to another demonstration. And this one is what I just did. So I apologize. I forgot to go to the slide. So this is just a graphic of what I just did. I cloned the GitHub down to my local. I made the commits. I synced it to my online GitHub. I apologize for not moving the slides forward, but this is a graphical representation of what we just went through. But the next demonstration is going to be working with someone else's code and data. So what we're going to do now is we're going to go out to the Kansas GIS site. So this one is not my online repository. I'm going to someone else's, and I found something really cool that I want to interact with. So I'm seeing here, this is for the GitHub webinar. I really like this. I want to make some changes to it. I want to use these for myself. The first thing you do is you're going to fork that repository. And when you do that, it creates a copy of that for you. So now you can see that I actually have a Davis GIS, that's my personal GitHub account, and I have an exact clone, an exact copy of the Kansas GitHub webinar up there at the top. So this is an exact copy of what Kristen and them have been working on, and it's on my online GitHub right now. But what we want to do is we want to say clone in desktop. and it'll launch the application. And it's saying, basically, I've already created this before, but for you, it would do the same thing it showed earlier. It would show that GitHub webinar was tell you to create it, put it in your folder, and it'll show you that everything was synced with no changes. But what I'm going to do is I'm going to come in here, and I'm going to look at the webinar description. And GitHub is a super cool primary tool in today's coding landscape. I'm going to save that to super happy, awesome, cool primary tool. And I will save that to my local repository. So you can see it was just changed. If I go back out here, you can see that it has the webinar text. My computer there. It says there's 2 changes because I made some changes earlier to a PowerPoint. And what I'm going to do is I'm going to say commit file. You would usually want to do a better description, but since we're doing this quickly, I'll just put that. So it committed the file to my local repository, and now I'm going to want to sync that up to my forked copy of this. So again, I'm in Davis GIS GitHub webinar here. I'm not on Kansas' site, and if I refresh, you should see here that 21 seconds ago, the webinar description.txt, about the 6th one down, says I committed the file. If we open it up, you're going to see it says GitHub is a super happy, awesome, cool tool. And again, this is in my local, not my GitHub, online GitHub account. So if we were to go back to Kansas, just to demonstrate that, now we are in Kansas' GitHub webinar account. If I go to the webinar description, you'll see that it does not have the super happy, terrific, or whatever it was I put in there. So when I'm collaborating with Kristen, I'm going to want to ask her to take my changes. I think my changes are some good changes that she's going to want to use. And this is where the pull request comes into play, and Kristen talked a little bit about that. And it's probably one of the hardest concepts to get with GitHub. But so now my online copy is ready to go, and I want to push those changes to Kristen's copy. You can come in here and say create a pull request. So it's saying I want to create a pull request from Kansas GIS webinar, from Davis GIS webinar. So what I'm doing here is I'm requesting that Kristen, when I click this button, take this change that I just made. So I've sent it to her. I pushed it to her. You can write any comments, but Kristen, whenever you get a chance, if you would merge that and see if it will show up. As you can see, Kristen said, I like those changes. I really like it a lot. I'm going to merge that into my branch. So when we go back we're back in Kristen's, the Kansas GIS branch. If we go to webinar description, we now see that it says GitHub is a super happy, awesome tool. We can go to history. We'll go to this last commit, and it'll show you exactly the changes that we made. So it's a way for us to collaborate. I made changes on my end, but I also thought it was a really good tool for Kristen to use as well, and she can either accept or reject that. So here we kind of get a little bit of overview description of what we just did. We forked the repo at the beginning. We made some edits in our local repository that's down there in our desktop when we cloned it to our hard drive. We committed those changes to our local repository. And as Kristen mentioned, that's a lot like saving a file. We then synced those up to my GitHub repository in the cloud, if you will, on github.com. And then we made a pull request to Kristen to say, hey, if you don't have to take this, but if you want this code, I've made some changes. I think you'd really like it. If you want to, go ahead and accept this request, and you can merge it in with yours, which is what Kristen did. Some common maintenance things that you can do with GitHub. One is issue tracking. And let's just go ahead and show you what that is. On the Arkansas GIS site, we use this for all of the GeoStore, for those that know about Arkansas GIS office. Well, it used to be known as GeoStore. It's now the Arkansas Spatial Data Infrastructure, but it's our online clearinghouse. And we've all collaborated on that using WordPress and using GitHub as our repository for all this collaboration. Well, when we did that, if we go into that one repository, you can see all of the code, all the GeoStore code is out there. You can see there's been 158 commits. You can tell just about anything you want to about this code. Well, we also used it for issue tracking. So over on the right-hand corner, right under code, there's issues. And you can come in here and you can create new issues. You can see all the pull requests that you've done. You can click on these issues and it gives you a little bit of information. I can leave comments to Richie saying, I'll just use a test issue right now. We can delete that later. I can make that comment. It gives them an email. So Richie is just now getting an email on this. It's a good way to kind of collaborate on code, but also keep track of issues and bugs. We can look at which ones we've closed over time and see how we close those. We usually put some comments in there about what we did. So it's a good way to track your issues as well as being not just a repository for your code. And another common maintenance thing that we mentioned earlier is the pull request. Since repositories, you can fork anybody else's repository, and even though they have the right to accept and reject that, the pull request is a way for you to ask the person whose code you're using if they would like to have a copy that you changed back. And if they do, they can simply merge that into their files, or they can reject it and not merge it at all. So geographic data, there's a pretty cool way that you can use geographic data in GitHub. One way is it's called a GIST, and that's a simple way to share snippets and paste with others. All GISTs are Git repositories, so they're automatically versioned and forkable. But this GIST is really a simple way for you to quickly put something out there that you didn't want to have a formal repository for. And what we're going to show in this demonstration is how we can use some simple JSON code, throw it in a GIST document, and then have it make an online map for us without us having to download anything. It's completely done online. Any of you can create an account today and do this in about 5 seconds. So I've created a quick code sample here. JSON, again, is a format for encoding a variety of geographic data structures. And the code is really simple, and it ain't going to let me click, so I'm going to come here. I'm going to copy and paste this code into a GIST. So GIST is at the top here where it says pull request issues in GIST. I'll click on GIST, and then I'll create a new GIST here, and I'll say a magic test map. The file name I'll use for that is magic test map. You have to say GeoJSON as the extension name. That's how GitHub knows to pick this up as GeoJSON. And then I'm going to paste that code that I had earlier. So I'm just literally putting a point, a lat long, and I'm going to say that live from Little Rock. That's all I'm going to put in there. So you can, and with GIST, it's a little bit different. You can create a secret GIST that no one else can see, but I'm going to go ahead and do a public GIST so y'all can go and copy this code later if you wanted to. So I'll say create public GIST, and it creates a map with a pop-up box saying live from Little Rock. I can go in there and edit that and say magic location, update that public GIST, and it automatically says magic location in the pop-up box now. This is a really cool tool if you wanted to test out some GeoJSON that you're working on to see if it even make a map, or if you had an issue with syntax or something. But it's also cool because you can embed this URL over here on the right. You can see where it says code revisions, embed URL. If you were to copy that to clipboard, you could put that JavaScript into any of your websites, and it would actually put that URL for this map in there ready to go. So it's just a really quick and dirty way to make an online map. The base map for this is OpenStreetMaps, which allows you to go in there and edit that street map if you wanted to. It's using Mapbox to do the tiles. It's a really quick and dirty way to make an online map. Another example, as Bob mentioned earlier, I do a lot of work with Syriaca.org, which is a clearinghouse for Syriac culture. And they have about 2,500 geographic places in the Middle East dealing with Syriac culture. And if you go to that URL right there, it's an API that will allow you to download any of the JSON in GeoJSON format, all of that data, and then you can put it in GIST and make a map. And as a matter of fact, I think I have one. I'm going off script here, folks, so hold on. I think I actually have a map using some of that data up here. Yeah, so here's one here. of some churches around Turkey and Iraq and Baghdad. Let's see. I think I have more. Here's, I think, all monasteries or something like that. I can't remember exactly what that was. But it's a real, GIST is a really good way to just throw a quick online map together using GeoJSON. And Kristen, with that, do you want to take over?
Sure. We do have some additional resources for working with GitHub, since, as you can see, it can get a little bit complicated pretty quickly. And a coworker of mine recently took an online course of how to use Git in GitHub that's free from Udacity. And so we've got the link up there, and we will be putting the slides up on the Magic website, hopefully. And I know that there are other full-blown courses available to do on Git or GitHub or both on other sites that can cost money. And so just as an FYI, there are also, GitHub does have a YouTube channel for guides on how to do specific things. And if you're just sort of interested in GitHub in general, they are a huge proponent of open data. And if you're a Twitter person, I'd highly recommend you follow Ben Balter. He was the keynote speaker at Magic a couple years ago, and so has a lot of good information about specifically open data in the government setting and other things like that. So there are just a few resources. You know, if you're interested in learning more about GitHub and how to leverage it, how all this forking and cloning and repository stuff works, there are good resources out there. There's also a lot of really not so great resources, so that can be more confusing than helpful sometimes, unfortunately. And what's the next slide, Tony? So in terms of questions, I think let's see, Bob.
Did we have any questions on the side while we were going? I wasn't paying a whole lot of attention.
Yeah, I wasn't either. No, I'm just kidding. No, thank you, Kristen and Tony, for that information. It was very, very good. Yeah, we did have some questions come in, and thank you for sending those in. There was a couple of questions kind of somewhat similar to each other. One was, will this presentation be available after this webinar? And how can we download the slides? Our intention is to make both the recording and the slides available from the Magic website, and we'll just put them out there, and we'll try to use the registration tool as a means to let you all know when that information is available. So we hope to make that available here as soon as we can. So thank you for that. There was one question, and it's basically, why would you fork somebody else's project instead of cloning it? And I'll
that's an excellent question, Bob. You want me to go ahead and answer it?
Yes, please.
Because I'm going to. The reason you would fork it first is for you to keep your own changes in your own repository. So if I made changes to that, if I cloned Kristen's without forking it, I would not have a repository of my own changes on GitHub.com. So all I could do at that point is I'd have a local repository on the computer, and I'd have to ask Kristen to accept my changes. And if Kristen didn't accept those changes, I wouldn't have an online store for that in my GitHub account. So if I fork it first, I've created my own snapshot of that code in the GitHub.com repository in the cloud. And then I can work with that. I can sync my changes to the cloud for storage without talking to Kristen about it. And then when I feel comfortable with that and want to send Kristen and say, hey, I'm done with this code, would you take it? I can then send a pull request. So it's a good way for you to have your own version of that without anybody telling you that you can't store it on there or make changes to it. And then at the end of it, if you feel comfortable with it and you want to show it to Kristen, you can ask for a pull request. So I hope that answered that question. You do not always have to fork a copy of something to interact with it. You can clone. I could have cloned Kristen's directly. I just wouldn't have been able to sync my merges directly to her repository.
Thank you, Tony. Appreciate that. I think that addressed that other question, and I think you had as well in the chat regarding that whether or not one must fork it first before you clone it. So I think we're good on that. The questions are really pouring in now. Another question, I have used GitLab in my work. What is the difference between GitHub and GitLab?
I've never used GitLab. This is Tony. I would make an assumption that GitLab is just like GitHub. It's a graphical way or another way to use Git, which has been a versioning tool that's been around for a very long time. It's usually used in command line, and there's a lot of different versions of it out there that do graphical kind of interfaces with it that allow you to use that versioning technology. So I would assume it's just a lot like GitHub, but a different version of it, a different company probably doing it. I don't know that for sure, though. I have not used GitLab.
Thanks. Next question, does GIST only work with maps? What other formats can it read and compile, such as Markdown?
It does not only work with maps. Anything you can put in GitHub, text documents, Word documents, PowerPoints, you name it, GIST would also work for that. GIST is just a quick way to, if you wanted to throw a code snippet or a text file or make a quick map, just a one-off kind of deal, that's usually what people use GIST for. So no, you're absolutely right. You can use it for .cs, you can use it for .json, you can use it for .json, .txts. Anything you can put in GitHub, you can put in GIST.
And I was looking at thanks Tony, I was looking at the chat, and Jerry mentioned for GitLab it is for local work, if I'm understanding your comment correctly there, Jerry. So I'm sure the rest of you saw that. Another question is there a best practices guide on some of the key items being discussed today?
This is for coders, and so there are very few best practices guides. Anything is just guidelines and personal preference and things like that. And so, everybody's going to have their own version of what those best guidelines are. So I don't know if anybody has a succinct version on absolute best practices for those things.
Thanks, Kristen. Jerry put in some more information regarding GitLab. I'm sure most of you can see that, but in case you can't, regarding the GitLab, where he had previously indicated is for local use, he mentioned that typically one stands up their own server, such as at the Jet Propulsion Laboratory, uses GitLab for their own use, and yes, it's for closed private development. So I'm assuming JPL stands for Jet Propulsion Lab, so if I'm incorrect there, I apologize, Jerry. Another question, is there anyone doing repositories around metadata?
Nathan, I'm sure there are. I'm not sure. I couldn't give you any examples right now, but I could search and get with you and let you know. I don't know why they couldn't. That's technically, actually it kind of is what Syriaca.org is. It almost is a big metadata repository clearinghouse of books and music, anything associated with Syriac literature or their community. So you should be able to do it just fine. It'll handle XML. It'll handle any format you want to use. So yeah, I don't know why you couldn't use it for that.
Thanks, Tony. Looks like there was relating to that. Nathan was thinking this could be regarding metadata resources, tools, Python, XML, and so on. So it sounds like that would match exactly what you said there, Tony.
Yeah, you should be able to, and I'm sure people out there are doing it. I can't think of one off the top of my head for some reason, but if I think of one, I'll shoot you an email. There's a lot of people out there doing it, I guarantee you. I'm sure Bill Dollins or someone like that would probably know for sure. He uses it quite a bit.
And fresh question, how does one go about searching for existing projects for stuff that one can use?
That is a great question. That is one of the so far bummers of GitHub, is it's extremely hard to search those things. I've tried, and you can sort of get some results, but not fantastic ones. since you never really know, with a search for metadata, I don't see any GIS metadata resources showing up. And so people call things very strange things, and I haven't had a lot of good luck searching for things. Projects that I have copied, I've usually seen as a link in a forum posting, or it's a direct from an Esri blog that they're pointing to a particular project. And so GitHub's particular search, I personally have not found to be extremely helpful. Somebody might, I don't know. And so usually it's links elsewhere on the web that go to a repository that I would be interested in.
And kind of to tag on to that, I agree with Kristen. It is very difficult if you're just looking for something out there because there's just so much. I mean, there's thousands and thousands of just little code snippets that people put out there. They do have a search feature here, as you can see on the screen. You can type in something. It does allow you to come down here and say, I only want to look at these 3 that are Python, and click that. And so if that's a language you work in. But like Kristen said, usually it's collaborating with somebody, and we know that they have a repository. You watch people, you star things. So I'm following 2 different individuals and people. There's people following me looking for things. So it's almost like a social network kind of deal. It does have a search feature, but it's not the most user friendly, like Kristen said.
Okay, I think that's it for the questions. I think if I missed one, I apologize, and if I did, please make a quick chat so I can catch it here. If somebody is typing in the chat, just as a reminder, we do plan to put this information up on the website, so be checking the website on a regular basis, themagicgis.org. And we will be trying to reach out for those who registered, so that we can let you know when the information is out there. Also, I just want to, as another plug for the Magic Symposium, which is coming up next April, put that on your calendars. There's information on the website that talks about that, and you can get it on your calendar. So anyway, unless there's any questions, I think we're finished. Anthony or Kristen, do you have anything else to wrap things up with?
No.
No, thanks everybody.
So, thank you all, and thank you again for attending this webinar, and we hope you have a good rest of the day and a good weekend. Thank you very much.